Let's do Brahmanad. Om. Om. Shanti. 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 Swastha. Dear student, now I will discuss a new chapter, that is your group 16 elements. Group 16 elements are also called oxygen family. The elements present in group 16 are oxygen, sulfur, selenium, tellurium, polonium. Among these elements, oxygen and sulfur are non-metal. Selenium and tellurium is metalloid. Polonium is a radioactive metal. Next, I will discuss about the occurrence of group 16 element. In our atmosphere, the percentage of oxygen is 21% by volume. Dioxygen also available in the form of the oxide, carbonate, nitrate, sulfate, etc. Sulfur found in different ore of sulfur. The different ore of sulfur are gypsum, epsom, galena, barytes. These are the ore of sulfur in which sulfur is found. In volcanoes, sulfur found in the form of H2S gas. Organic material like onion, garlic, egg, mustard, etc. contain sulfur. Selenium and tellurium are present as metal selenides and tellurides in sulfide ores. Polonium is present as a decay product in the thorium and uranium mineral. These are the occurrence of group 16 element. Next, I will explain about the trends in properties of group 16 elements. At first, I will discuss about the trend in physical properties. At first, I will discuss about the electronic configuration. The general outermost electronic configuration of group 16 element is NH2 NP4. The first element present in group 16 is oxygen, next is sulfur, next is selenium, next is tellurium, next is polonium. The atomic number of oxygen is 8. The electronic configuration of oxygen is helium 2s2 2p4. The electronic configuration of sulfur, which having atomic number 16, is neon 10 3s2 3p4. Next is selenium, which having atomic number 34. The electronic configuration of selenium is argon 18 3d 10 4s2 4p4. Next element is tellurium, which is having atomic number 52, and the electronic configuration is krypton 36 40 10 5s2 5p4. Next element is polonium. The polonium element having atomic number 84. The electronic configuration of polonium is xenon 54 5d 10 4f 14 6s2 6p4. These are the electronic configuration of group 16 element. Next physical properties: atomic, ready, and ionic ready. The atomic ready and ionic ready of group 16 element is smaller than the atomic ready and ionic ready of group 15 element. This is due to the more effective nuclear charge of group 16 element as compared to the corresponding elements of group 15. The atomic ready and ionic ready of group 16 element goes on increases from oxygen to polonium. This is due to the addition of new cell. Next physical property is ionization energy. The ionization energy of group 16 element is higher than the corresponding elements of group 15. This is due to the small size of group 16 element as compared to the corresponding element of group 15. The ionization energy of group 16 element goes on decreases from oxygen to polonium. That means oxygen having highest ionization energy. On the other hand, polonium having lowest ionization energy. Next physical property is electron affinity. The electron affinity of group 16 element is higher than the corresponding element of group 15. This is also due to the small size of group 16 element as compared to the corresponding element of group 15. The electron affinity goes on decreases from oxygen to polonium. This is due to increasing in the atomic size from oxygen to polonium. Next physical property is physical state. Oxygen exists as diatomic state while sulfur, selenium, tellurium are exist in octa-atomic state. On the other hand, polonium is a radioactive Next physical properties, melting point and boiling point. The melting point and boiling point goes on increases from oxygen to halogen, then decreases. These are the physical property of group 16 element. Next I will discuss about the trends in chemical properties. First, chemical properties, oxidation state. Except polonium, all the elements are divalent and shows -2 oxidation state. However, sulfur, selenium, tellurium also shows the oxidation state like +2, +4, +6. Next, chemical properties, formation of hydrate. All the elements of group 16 can able to form hydrate. For example, H2O plus O2 gives H2O, H2 plus S gives H2S. You can also write H2SE, H2T. Next I will discuss about the trends in characteristics of hydrate. First characteristics of hydrate is volatility. The trend in volatility of hydrate is H2O smaller than H2S greater than H2 Se greater than H2T. The high boiling point and low volatility of water is due to association of water molecule through hydrogen bond. Actually, the volatility goes on decreases from H2S to H2T. This is due to increase in the molecular weight and also increase in the van der force. Remember an important point, with increase in the molecular weight and increase in the van der force, always the volatility decreases. Next characteristics of hydrate is acidity. The increasing order of acidity of hydrate of group 16 element is H2O smaller than H2S smaller than H2Se smaller than H2T. This increase in the acidic strength of hydrate of group 16 element is due to increase of the size of the central atom present in the hydrate of group 16 element. Since the atomic size of oxygen is smaller than sulfur and the atomic size of sulfur smaller than selenium and the atomic size of selenium smaller than tellurium, as a result the covalent bond strength goes on decreases. This is due to increase of the atomic size of the central atom. Suppose I want to draw the structure of H2O, then the structure is like this. Similarly, the structure of H2S is like this. Similarly, the structure of H2Se is like this. The structure of H2Te is like this. Look at that. here the bond length goes on increases like this, because the size of the central atom goes on increases from oxygen to tellurium. Due to increasing in the bond length, the bond strength goes on decreases. That's why less amount of energy is required to break to this bond, as the bond dissociation energy is very less as compared to the other bond, so the cleavage of this bond is more easier. That's why the H plus can easily released from this molecule and shows more acidic character. So I can write the increasing order of acidic character of hydrate of group 16 element like this: H2O smaller than H2S, smaller than H2SE, smaller than H2TE. Next characteristics of hydrate is thermal stability. The thermal stability goes on decreases from H2O to H2TE. That means the thermal stability of H2O greater than H2S, greater than H2SE, greater than H2TE. This is due to increase of the size of the central atom. With increasing the size of the central atom, the covalent bond strength goes on decreases. That's why the thermal stability also goes on decreases. Next characteristics of hydrate is reducing character. The thermal stability of hydrate of group 16 element goes on decreases from H2O to H2TE. That's why the reducing character goes on increases from H2O to H2TE. So I can write the order like this: H2O smaller than H2S, smaller than H2SE, smaller than H2TE. This is all about the characteristics of hydrate. Next I will return to the other chemical property of group 16 element. Next chemical property is reaction with the oxygen. Sulfur, selenium and tellurium can react with oxygen to form two type of oxide. One is your MO2 type oxide, another is MO3 type oxide. Here M means sulfur, selenium, tellurium. The MO type oxides are SO2, SeO2, TeO2. The MO3 type oxide are SO3, SeO3, TeO3. Remember, the trioxides are more acidic than dioxides. Next chemical property is reaction with the halogen. All the elements can react with the halogen to form a number of halides. Oxygen can form the halide like F2O, ClO2, Cl2O, etc. Like oxygen, sulfur can form halide like H2F2, H2F4, SF6, etc. Like sulfur, selenium can also form Se2F2, Se2F4, HCl4, HCl6, etc. Tellurium can form TeCl2, TeCl4, TeCl6, etc. Polonium can also form PoCl2, PoCl4, PoCl6, etc. These are the list of halides of group 16 element. Generally, the group 16 element in the halide shows +2, +4 and +6 oxidation state. Sulfur, selenium and tellurium can form hexafluoride such as SF6, HCF6, TF6 respectively. Hexafluorides are octahedral and sp3d2 hybridized. Tetrafluorides are sp3 dehybridized and having structure seesaw structure. Except selenium, all other elements can able to form dichloride and dibromide. Remember, the dihalides are sp3 hybridized having band structure. Next chemical properties: formation of oxides. Sulfur, selenium and tellurium can form similar oxyacids. These are formed by the reaction of dioxide and trioxide with the water. The elements sulfur, selenium and tellurium can form two types of oxyacid. One is your H2MO3, another is your H2MO4. The H2MO3 type oxyacid are H2SO3, next is your H2SCO3, next is your H2TO3. The H2MO4 type oxyacid are H2SO4, H2SCO4, next is your H2TO4. This type of oxyacid can be formed by the reaction of dioxide with the water, and this type of oxyacid can be formed by the reaction of trioxide with the water. The strength and stability goes on decreases from sulfur to tellurium. Here M equal to sulfur, selenium, tellurium. This is all about the chemical property of group 16 element. Next I will discuss about the anomalous behavior of oxygen. The anomalous behavior of oxygen is due to number one is small size of oxygen and also oxygen having high electronegativity. Second is absence of vacant d orbital. Due to small size and high electronegativity of oxygen atom, the oxygen atom carry partial negative charge in water water molecule and the hydrogen atom के लिए partial positive charge. Due to partial positive charge on hydrogen atom and partial negative charge on oxygen atom, the water molecule able to form hydrogen bond. Due to presence of hydrogen bond in water molecule, water is a liquid. On the other hand, due to absence of hydrogen bond in H2S, H2S is a gas. Due to absence of vacant orbital in oxygen atom, the oxygen atom shows maximum covalency 2, while other elements expand their covalency up to 6. Next I will discuss about the difference of oxygen with the other elements of group 16. If I will compare the oxygen with the other element, then the first point is oxygen is a gas while other elements are solid. Next point is oxygen exists as diatomic state while sulfur, selenium, tellurium exists as octaatomic state. Oxygen can form only one compound OF2 with the +2 oxidation state, while the other element can form several compounds with the +2 oxidation state. In case of oxygen, the di-negative ion is common, but in case of other element, the di-negative ion is very less. The covalency of oxygen is maximum 2, while the covalency of other element expand to 6. Oxygen is paramagnetic in nature while other elements are diamagnetic in nature. Oxygen is a more stable while the stability of other element is less than the stability of oxygen. Oxygen is a non-metal, but in case of other element, sulfur is a non-metal, selenium and tellurium are metalloid, polonium is a radioactive metal. This is all about the difference of oxygen with the other elements of group 16.